see it a lot. So hopefully you can see the screen show up. All right, so sine graph, cosine graph, you should have already memorized. One star at a 0, one star at a peak. That's the easiest to remember it. And that you should know what is period, what's trout, what is amplitude, and what is the midlines. And we're gonna go through them really quickly. So why it's not reacting? So all right, that's good. The best thing is have a graphing paper for this section, or print out a graphing paper. I give it to you. If you have graphing paper, it will help a lot. So let's just review really quickly. Those of you guys not here, basically we just take the sine graph and we do a t-chart. And the t-chart, I'm not gonna use all the points right now. All the points right now, for me, I just need you to know those certain points. If I were to give you a quiz today, then you should know this point, 0. Sine of 0 is what? Sine of pi over 2. 1. Sine of pi. 0. Sine of 3 pi over 2. And the sine of 2 pi. 0. So then your graph should have been this. I'm gonna make it bigger. You should have this. So let's just say I hear, and I hear. So the graph should be, it's not a straight line. Straight line is gonna be absolute value, but this is actually curvy line like this. And it's gonna go in like this. And those are the 5 major points. So remember, those are 5 points. You start at a midline, go to the peak, go to the midline, go back to the trout, and go to the other side. Now the cycle is going to repeat. So technically go this way. A lot of people don't know how to go this way. This way it's going to go down instead of go up. Okay. Well, depending which orientation you come from. This and this and this. This is a classic 2-period sine graph. So we already said this is the max. This is the min. And what's the distance from here to here? Amplitude, but in this case is 1. Thank you. The amplitude is 1. It can be from here to here as well. Now remember, amplitude is from the maximum to the midline, and that's the amplitude. Now where is the period? Very crucial that you guys know what a period is. 0 to 2 pi, thank you. So I'm going to say it's from 0 to 2 pi. Now you should see that this graph from here to here, that is going to be a period. Now it turns out from here to here, it's also a period. So, but basically just the whole graph go through the whole cycle. So there's 2 cycles here. So we call it 2 periods. If I were to give you a quiz, this expectation I should know. is, do you know what the period is? Do you know what the amplitude is? Do you know where the midline? Where's the midline? The x-axis. Thank you. So this is called a midline. And that's the middle of everything. Now let's go to cosine graph. So y equal to cosine of x graph. What's the difference? It's going to be, if I start at 0, what am I going to get? 1. If I start at pi over 2, 0. If I start at pi, -1. If I start 3 pi over 2, and 2 pi. Okay, so I'm going to mention also something else I need you to know is domain. What is the domain of the sine function? Domain is negative infinity to infinity. And range is going to be what? -1 to 1. Okay, so that's all the information you know. One last thing I need you to know for sine function. Is this an odd or even function? Why did you say even?
Because it's like a reflection of the y-axis.
You have one specific part is, yes. Thank you. It is good. Reflection to the origin. So it's even or odd? Odd. Just think about your face. You don't want your face to be odd. This is symmetrical. Hopefully. I mean, generally. Normally, everybody's not perfectly symmetrical, but generally, they are symmetricals. So your left face should look exactly, your right face should even. You don't want your face to look odd. So if it's even, then think about if you were right about symmetry to y-axis. Symmetry to y-axis is actually even. This is your y-axis. This is your y-axis. That should be even. Okay? So this is actually odd functions. So odd functions, because they are symmetry to origin. And the reason what I can tell is I can plug in another point to negative pi over 2. What is sine of negative pi over 2? Annika? What is sine of negative pi over 2? -1, good. Now if you pay attention, this and this are opposite. One is positive one is -1. They're symmetry to origin. And they are odd because they are symmetry to origin. Now this one is, if I do 2 pi, that's going to give you 1. So I'm going to go ahead and graph it. And I'm going to go here. Sorry, it's wrong side. I'm going to start at 0. I'm going to go here, 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 here. So the graph should be like this. And remember, it's not a straight line. Those of you guys graph a straight line. And from here to here is a period. And from here to here is amplitude still. And from here to here is going to graph on the other side. Now, this is like your face. Think about it. If this is your face, that, like this is your face, this is symmetry to y-axis. Symmetry to y-axis is even. So this even function. So if domain here is going to be negative infinity to infinity, range is going to go in from -1 to 1. The only thing different is this is the even function. you have to know this. Now I'm going to talk about one thing that's on SAT a lot. On SAT a lot, they really emphasize on something called co-function identity. Co-function identity is study the sine function and cosine function. What do they have? Are they the same? They are technically or exactly the same graph, except there is a shifting of 90 degree or pi over 2. If you think about it, if I take this, right? If I happen to, I don't know, if I happen to take this graph and shift just tiny, oops, I cannot do that. But I can shift the whole graph to the left, right? Pi over 2, then that will give me an exact same graph. Shift whole graph left pi over 2. So that is going to give you something called co-function identity. Robert, that phone is going to be out of window. You want to test my baseball skill? Okay, so the whole graph can shift left. So what is co-function identity is? Ian, wake up. This graph can shift left or right. But usually I will take the sine graph, shift left. So it's going to be plus pi over 2 or negative pi over 2, doesn't matter. So let me give you correct shifting, otherwise I don't want a mistake. Give me a second. Okay, so sine of theta is equal to cosine of pi over 2 minus theta. And cosine theta is equal to sine of pi over 2 minus theta, or equal to cosine of 90 degree minus theta, sine of 90 degree minus theta. Tangent of theta is equal to cotangent of pi over 2 minus theta, or equal to tangent of 90 minus theta. Very important that you know this. I'm gonna prove to you this is true. Yes. Huh? Zoom in, yeah. So this is on SAT a lot. I'm gonna show you how to word it. I'm gonna prove to you very easily that what's on SAT is gonna be exactly the same thing. Yes. But this should be cotan. You're right. Thank you. Okay, so this two happen most. This happened most here. Why? Yeah. You can just get your calculator out. Just type in sine of 23 degrees. Type in sine of 20 degrees. It's equal to what? Cosine of which degree? Can you guys guess? It's equal to cosine of which degrees? 67. Why 67?
Because you subtract 23 from 90.
Yep. So 67, and try it. Type in sine of 23 degree and cosine 60. Make sure your calculator is in degree mode. Then you can actually see that that's true. And this is on SAT. Why? I'm just gonna pick a random SAT questions here. I'm gonna go back. I'm gonna say it's okay. Oh no. And some every single SAT now. This is the question that you gotta be able to differentiate. So I don't know why this one sounded. So SAT practice. Actually, let me see. SAT. SAT practice. Okay, so open practice. This is a the this is one of the things. So we're gonna go in to look at it N. Okay, maybe it's this first section. Okay. What's the answer for this one? Write it down the question. You're gonna see this often. This is the easiest hard question on SAT. Do you know the answers? Do you need a calculator? You don't need a calculator. This is a non-calculated section. How many of you guys got an answer already? One person? Good. I need more than one person though. How many of you guys got it already? Julia, nice. What do you think the answer is, Julia? Nope. That's not one of the questions. Bennett? 4/5 is the right answer. Because sine of this and this are the same, right? So the answer is just 4/5. And I prove to you it's true. I'm gonna prove to you it's true. So obviously, this we know this is a triangle, right? It has angle X. Is that okay? Is this okay? This is 90 degree because SOHCAHTOA. Am I going too fast? No, this one is going to be 4 and 5. Is that okay? Now, here's my question. What is this angle? What is that angle? En, what is it? 90 degree minus X. Why is that? Because if this is, let's say, if this is 20, right? What's the other one? 7. Because 90 minus 20. Does that make sense? This becomes 90 minus X, right? So technically, if I do cosine of 90 minus X, it's adjacent over hypotenuse. So still over 4/5. Does that make sense? So regardless, in this situation, not all the time it's like this, but this particular question are a true idea of cofunction identity. Basically, I'm just using the other, it's called complement angle. If I do opposite of that angle, complement of that angle, it's going to be exact same thing. Does this make sense? You should see this on SAT. At least I don't know if the digital SAT still have this, but this is the last SAT that you take in December, you should still have this. But digital has some changes. I don't know a specific change. I tried a blue book. Everything's got a lot easier. I don't recall if I see sine and cosine, but I could be wrong. But yeah. Is that okay? Okay, so we take care of the cofunction identity. We're gonna go back to learn how to graph. So first of all, we're gonna learn how to graph this. Sine A to the bx. Now the real version, this is the easier version, so easier version. The real version is look like this. This is eventually, hopefully, we can graph this at an end. So, but we're gonna start with this. We're gonna start y equal to a sine of bx. Or y equal to a cosine of bx. They are just one star at a peak when one star at a trough. Here could be like this, a cosine of bx minus c plus d. So this is the final version of have all different kind of shift. And this, we're going to start with the easier version. So hopefully we'll get through the first part today. It's not hard. What's the difference between sine and cosine graph again? Sine start at where? Sine start at the midline. Okay, so I'm going to write down sine start at midline. So sine start at midline. Cosine start at peak. Is that okay? Now I'm going to graph this. Y equal to 3 sine of 2x. Now, first of all, what do you think that 3 do to the graph? Let's go like what Yen does. It goes like, right? Okay, so he's kind of like show you what a graph, if you were to put it in the body language. But look at here, sine of x, like this. And if I put an a in the front, and I'm gonna add a slider. Oh, SAT, make sure you know how to use slider. This is really cool. This is what a sine graph do. The a value in the front is increase the amplitude. Go up, come down. If a is negative, it's going to flip over. Does that make sense? Can you guys see? I'm going to make it this. Does that make sense? Now, what does a b do? So what if I change my b from a 1 to a 2? What do you think 2 do? Yes.
Move to the right or left too.
I don't know. Okay, could be. I'm not saying yes or no. Anybody else any ideas? What is it? If I change this a to 2, and let's just say right now I have a sine of 1x. If I change that to 2 sine of 2x, what does the graph do?
Let's get wider.
It gets wider. The periods it gets wider. Okay, let's show you if it gets wider though. Do they get wider? It gets smaller. So that's called a compress. If b is greater than 1, it's actually compressed. And then we're gonna talk about that, how much it compressed, right? We're gonna describe that. So we're gonna try this. So the first thing that we're gonna do is we're gonna write down the amplitude. Amplitude I'm gonna write down as absolute value of A. So absolute value of A here. So in this case is 3. Is that okay? And then we're gonna go in. We're gonna say, okay, well, I'm gonna find out what my period is. Period is, if you're gonna look at here, we said, well, period has a formula. It's called 2 pi over b. 2 pi over b. This formula you have to memorize. So period equal to 2 pi over b for sine, cosine, secant, and cosecant. Secant and cosecant. So for all this, it's always 2 pi over b. Always 2 pi over b. So in this case, we're going to get 2 pi over 2 because b is 2, right? So that's equal to pi. Is that okay? So period is pi. So in this, one more idea is I always told students to find out 4 quarter periods. So it's called quarter periods because usually graph is graph to 5 points. You want to cut it to 4 sections. Quarter period is going to be take this pi and divide by 4. So it'll be pi over 4. So that's what quarter period is. Is that okay? Mm-hmm. What you got from period and divided by 4. So if you got the period is, I say, pi over 2, then it's going to be pi over 8. Is that okay? Can somebody answer that? So then I'm going to take this function. What did I say?
The call could not be completed.
Okay, great. So now the amplitude is 3, so I'm going to go up, down by 3. So this is where I start. And I'm going to start at here. Now they say a quarter period is what? Pi over what? Pi over 4. So what I'm going to do is I'm going to just increase each one by pi over 4. So exact same distance. Pi over 4. Now the next one is going to be 2 pi over 4. Does that make sense? 2 pi over 4, can I simplify down to what? Pi over 2. 3 pi over 4. And the what? Pi. So now you see this graph is going to go up. And this is come down. And this is going to go down. So same exact graph, except my scale is changed. My scale, the whole period is take only pi. Do you see that? This is only pi. As opposed to before, what's my period? 2 pi. So this one is equal to 2 pi. I forgot to write it down, but this is 2 pi here. It's shrink down to exactly half. So it's pi. And scale-wise, I'm going to say it's negative pi over 4. Negative pi over 2. Negative 3 pi over 4. and negative pi. So then that's going to give you this, 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 this. Is that okay? So you're going to graph one. Y equal to. Now, what happened if I have a negative 3? If I were to graph negative 3 here, what will happen? The amplitude doesn't go down. The amplitude stays the same. It flipped the other way, right? Does that make sense? It goes the other way. So I'm going to ask you to graph negative 2 sine of half x. So sine of half x. You're going to change your scale. Today you're graphing it. You're going to change your scale. But each increment I will want you to remain is it a 2 space or 1 space. It's up to you. It's up to your preference. You decide the scales now. Now you gotta know that negative 2 is starting midline by going down rather than going up. So those are the things that you should be able to pay attention. Ian? You're staying awake, but you're not paying attention to what I'm doing. So it's not much better.
Line they're calling. Yeah, it's Sarah.
Yeah, she's not here, right?
No, she's not here.
Start with the amplitude. What is my amplitude? Is equal to 2. Now, what is my period? It's 2 pi divided by 1/2, right? So that means 4 pi. So that means what? Quarter period is what? Pi. So you should have all this information right down. Now, a lot of people hate graph. You cannot just write down information. They stop right there. They don't go any further. You have to go in to graph the scale now. Each quarter period is going to be a scale of pi, 2 pi, 3 pi, and 4 pi. And I'm going to go backward. Negative pi, negative 2 pi, negative 3 pi, negative 4 pi. Now I'm going to start from here because start at the midline. But this is a negative. It has a reflection. So it's going to go down 2 units. So every major change, it happened at quarter periods. Does that make sense? Is this okay? Is this okay? Now I'm going to go in to try to graph the next one. I'm going to graph 4 cosine of 2/3 x. 4 cosine of 2/3 x. Now cosine doesn't start at 0 now. It starts at a peak. So you have to be very cautious when you're doing this stuff. Yen, you're gonna get a piece of paper, graph it, because I know your iPad's out of battery, but you haven't done any graphing. You didn't even draw down the notes. You didn't do anything. So when you go home, completely lost, take a test, don't know where to start. So you gotta learn to do things on task.
History, can you zoom in?
Sure. Shooter X. So today's goal, we're just gonna grab the easier version of sine and cosine. Tomorrow we're gonna go to a harder version. Yeah, do you have a paper or pencil? So I know your iPad's out of battery, but you did not do anything. What? Then you ask somebody to borrow one. If you're gonna use an iPad, you gotta charge your iPad. This is the third time you didn't charge your iPad. Okay, so I'm gonna go start. What is my amplitude here? Write down 4. What's period here? Huh? It was 2 pi divided by 2/3, right? So it'd be 2 pi divided by 2/3. Write it like this. 2 pi times 3/2, right? So the answer is what? 3 pi. Good. What's quarter period? So 3 pi over 4. So quarter periods is going to be equal to 3 pi over 4. Now that means each scale I'm going to increase exactly 3 pi over 4. Those of you guys cannot count, just count the numerator is increased by double. So I'm going to say 3 pi over 4 here. The next one's going to be what? Which is 3/2, right? Is that okay? And the next one is 9 pi over 4. So think about this is 6 pi over 4. This is 9 pi over 4. I will always do it and just simplify it later. So that's 12 pi over 4. And I'll simplify that's 3 pi. And same thing is here. Negative 3 pi over 4. Negative 3 pi over 2. Now I can copy on the other side. 9 pi over 4. And 3 pi negative. Cosine star at a midline? Or star at where? The peak. Where's the peak? 4. This is the graph here. 4. That means next thing, if you start at a peak, it has to go down, right? But you don't stop here. A lot of people stop right here. You keep on go down further because you had to go to the trough. Does that make sense? So you're going to go to the trough, which is 4 unit down, up. And that's it. So that's today what you have to be able to do. Yeah, some practice today. Make sure you do practice.
Ignoring anything else. I've been sleeping like 12 hours for the past 5 days. I cannot. What? You know it's simple.
I have to go to Mr. Greenhouse after this. And like, if I be late, he's gonna like. Mr. Yi is really sprinting across the whole school.
If we're doing the inverse line or something, we take the inverse first, and then we take the direction.
Yeah. Yeah.
Thank you so much.
Are you sick? You okay?
I'm just looking so.
He's literally sprinting across the whole school
25 minutes.
with the paper. Everyone must think he's actually crazy.
He is crazy. He's genuinely mental.
He's definitely insane. Okay. Bye, Luke. I'll see you.
Good luck, or whatever you're doing for your mom. What is Bill gonna do? He's running right now.
Huh?
Dude, I forgot to do basic inspection.
Just trying to get this over with.
Okay.
I just want to get this over with. I'm doing this for like 5 days.
For animals, basic integration.
Like
you gotta
mentally.
really use yourself. Everything's on the page. Like almost everything.
Yeah, pretty much. Except for some of the E ones aren't ESA, but other than that. Well, even the E ones are ESA.
What do you mean?
The exponents.
Exposed. Like.
You.
Oh, no, that's okay.
Okay.
That's. Wait, what?
Guys, you ready to cook?
Yeah.
Quick, grab everything on the board. Please. Order everything.
He's running the guy faster.
Every time. I've already accepted my L. I got my L. Yeah, I know.
I think in general,
Yeah, please, that's so bad. I know. He's giving up, dog.
I'm not taking the L till after the test.
If I try not to get nervous, if I get nervous, I'll go like this.
Wow, we're waiting for time.
He's running the test. He's running the test. He's not good. He's literally putting his legs and racing across the floor.
I'm not surprised.
Because I was doing this, and then realized like if you have like maybe like 2 thirds.
Oh, I just realized that's that's.
Oh.
Inverse. Like that?
No, that,
No,
that,
no, the
that.
others. Yo, this is hard.
Alright, ready to rock and roll?
You just want to raise your dose.
I'm ready to roll when we're not around. No mistake.
Right in E. Please.
These are my not sick.
Do the question you know how to do first. If you don't think good first, you don't know how to. Don't get stuck in the question. Oh, sorry, Jason. Always start thinking simple first, and simple cannot do, you can do something harder. So don't try to overthink the questions.